As you people were saying that we are having a problem in solving the question which I gave related to queue operation. So as we have discussed the queue operation, now I will solve one question. So let's see if you people are able to understand. Let me just check where that question is. Queue operation queue. Yes, so here it is. It says that the diagram below represents a queue abstract data type that can hold a maximum of 8 items. Like there is a queue which has been created and it can have 8 items. Move on. The operation of this queue may be summarized as follow. The front of queue pointer points to the next item to be removed, and the end of queue pointer points to the last element that can be added. The queue is circular so that empty storage elements can be reused even if we want to. So front of queue will be pointing to the next item to be removed, and end of queue pointer points to the last element which has been inserted. So as I told you earlier, that front pointer is incremented when an item is removed and end pointer is incremented when we want to insert an element. This is all based on the same principle. And here they are saying that the queue is circular. What does this mean that the queue is circular? Queue is circular means that if it is going to point to the end of the queue, then value can be incremented quite easily. How octopus is added to the given queue? Now what will happen, as we know that we want to add something, when something needs to be inserted, then end of pointer is incremented by 1, which means that this arrow of end of queue is now pointing towards location 4, and octopus will be stored at this location 4. So what you are going to write? You are going to write, because this question says describe, which means you don't need to solve anything. You just need to write the explanation. So you need to be very careful and very clear about the explanation that what it is asking. 1 mark you will be given for writing that end of queue will be incremented by 1. So you can write that EOQ is incremented by 1 or pointing to location 4. Pointed to location 4. And what will be the other point which you can tell that octopus will be stored at location 4 of the list. Octopus will be stored at location 4, that is pointed by end of queue pointer, right? So this is how you are going to answer. Describe how the next item in the given queue is removed and stored in the variable animal name. Now what is the next element now? Next element refers to that the element which needs to be removed out of the queue. So what element needs to be removed out of the queue? It is currently first in first out operation. Na? So frog will be removed, right? So next item to be removed is frog, because frog is pointing towards the front of queue pointer now. So value, so what you are going to write, because again in this question also you have to describe value frog pointed by front of queue pointer which is at location 0. This will be assigned to variable animal name. So very easy, frog which is at currently representing or pointed by front of queue pointer f of q, which is at location 0. It will be assigned to the variable animal name. I'm repeating again. Frog, which is pointed by now front of queue pointer at location 0, will be assigned to the variable animal name. And now since this value has been removed, so where front of queue pointer will be pointing to? Front of queue pointer will be pointing towards cat, because frog has been removed and front of cube. As I told you earlier, front of cube pointer is incremented by 1 when an item is removed. The first question was about adding, so that's why we used an increment end of queue pointer. Now this question is related to how an element needs to be removed. So how you are going to get 2 points? First point or first mark you will be given for that value frog, which is pointed now by front of queue pointer at location 4 at location 0. This will be assigned to the variable animal name, and now front of queue pointer will be pointed to cat, right? So now we are going to proceed towards the next part, which is describe the state of the queue when front queue and end of queue pointer have the same value. Obviously, look, currently end of queue pointer is at location pointed to by cat, which was location 2. Let's say here we have cat, and then after cat we have fish, and after fish we have elk. And end of queue that is represented here by E, and front of queue which is represented, let's say, by F is here. Now we want to check that when end of queue pointer and front pointer will have the same value. Let's say we want to remove another element. Cat has been removed. Now front of queue pointer will be moved towards fish, and then we have another operation when we have another element removed from this list. So fish is removed. Now fish has been replaced, removed, cat has been removed. Now only elk is present, which means that when front of queue pointer and end of queue pointer are going to have the same value, when there will be only one item available in the list. So you in the queue. So what you are going to write? You can write that when the front of queue and end of queue will have the same value, it represents that there is only one data item present in the queue, right? So then we are going to move on towards the next part of this question. Some operations are carried out on the original queue in part A. We are going to carry out few new operations on the original queue which we solved. The current state of the queue is frog at location 0, cat at location 1, fish at location 2, and elk at location 3, right? So what now we need to do? Complete the diagram to show the state of the queue after the following operations have been carried out. What are the operations? We are going to add West, then we are going to add B, and then we are going to add mouse, and then we need to remove two items. Okay, now first of all, the first thing you need to do is where front of queue pointer is referring to. Front of queue pointer is referring to here frog, front of queue, and end of queue pointer is referring to elk, which is E O Q, right? So now what we are going to do, we have to add three elements now. So for adding elements, what you have to do, let's say we added wasp, then we added bee, then we have to add mouse at location 6, right? And now end of queue pointer will be pointing towards mouse. So EOQ is at location 6 at mouse. And after that it says you have to remove two items. So what two items will be removed? Frog will be removed, then cat will be removed because front of queue pointer is incremented. And now front of queue pointer will be pointing towards fish, and end of queue pointer will be pointed towards mouse, right? So let me just erase the extra information. What will be our final answer? we have fish, which is pointed to by front of Q pointer, and mouse is represented by end of Q pointer, right? Easy. So moving on towards the next part of it, in which the state of the queue after other operations are carried out is shown. Now they are representing or telling us the state of the queue after we have applied some other operations. Now this part, which is elk, is representing the FOQ pointer and mouse is representing the end of queue pointer. Now we have to complete the following diagram to show the state of the queue after the following operations are carried out. Now, in the initial part, we discussed that the queue is circular. Now, what does this mean that the queue is circular? Queue is circular means that if there is an empty location which is pointed by some element, then we can remove that element quite easily, right? So, what we are going to do, we have to show the state of the queue after the following operation. We have to remove one item. Now we have to remove one item, which means that item is removed by using this index front of queue, right? And it means that elk will be removed and FOQ pointer will be pointing towards wasp, which is at location 4. So I can write over here wasp and it is pointed by location 4, which is FOQ, and it is at location 4. Easy. Right now, what I'm going to do in the next part, they say that we have to add two elements which are dolphin and shark. Now, when end of queue pointer is when the element needs to be inserted, it means we are going to change the value of end of queue pointer. So when incremented by 1, it will be now pointing towards end, and now another end of queue operation needs to be referred. So as the queue is circular, so another operation will take the end of queue pointer to location 0 where the frog was present, right? So end of queue pointer is referring to here location 0 where frog was present, right? And we have to add two elements, dolphin and shark, right? So in the first operation, when one element need to be inserted, then ant will be replaced by the first element to be inserted, which was dolphin. So dolphin comes in place of ant, and now shark needs to be added. So now instead of frog, shark will be present over here because two operations of end of queue pointer were used to add dolphin and shark. So when end of queue pointer was referred to location number 7 incremented by 1, then dolphin comes in place of ant, and after that when end of queue pointer was incremented by 1, so frog will be replaced by shark. So I'm going to write here, first of all we have shark at location 0, then we have cat, then we have fish at location 2, then at 3 location we have ELK elk, and after that at location 4 we have wasp, at location 5 we have bee, at location 6 we have mouse, and at location 7 we have dolphin. And where the elements are pointed to, elements basically 4 is pointed by FOQ, front of queue pointer. Data was taken from here. And now shark was representing end of queue pointer here. So this way. And plus you need to place a bracket over here, cat, fish and ELK. Why? Because these values state was not changed. They were used as they were. So I hope if you are able to understand this question clearly, it will become quite easy for you to understand the concept of queue. Similar type of questions can be asked. This was question from your exam in May June 2021. So see you in the next.